the basic amplifier configuration. So in that we have seen in detail with respect to that of BJT amplifier as well as MOSFET amplifier in detail, and we have seen so what are the properties of an amplifier and how the amplifier will be performing well with respect to variations in the temperature or anything it is concerned. So how it is going to avoid. So, what are the different problems associated with the biasing network we have seen. And after all, seeing all these things, so we started finding in the first module about them. We have find out in the first module that among to provide a stabilized bias network. So once the stability of the network is done, so that means the amplifier will be operating with corresponding Q point. Then when it is operating with corresponding Q point, then the current as well as voltage characteristics is also going to be get fixed. So once it get fixed, so obviously the thing is that so the amplifier will be for a given set of input. So if you apply small signals, that means it is going to give a large amplification. So provided that you have to maintain such a way that the biasing of the circuit will be maintained constant. As long as the biasing will not have any issues, so you will be having the maximum amplification will be having. So that was the thing that we have seen in the first modules, and we have overcome those biasing network problem. Along with that, we have seen for both the case of BJT as well as the MOSFET case, and small signal equivalent model for both BJT as well as small signal model for both BJT as well as the MOSFET. And we have seen so what are the current expression and the current relation that are going to be existing between the each of the transistor, and we have obtained so what are the how much the amplifier is going to provide a gain. So everything we have seen in the first two chapter, and in the second chapter module, so we have just seen what are the causes in detail about the MOSFET only. So we have considered MOSFET as a transistor because in higher most of the ICs will be made up of MOSFETs, and MOSFETs will be providing very suitable application. So because of its high impedance and low output impedance, as well as so much gain it is going to provide. So normally, so all the transistors will be basically it will be made up of it will be made with respect to MOSFET itself. So it is going to have a high noise margin. All these important parameters are associated with MOSFET. Hence, along with the BJT, so MOSFET is also gaining importance. So because of that, the MOSFET is widely used nowadays. So for all the ICs applications and also all the transistor basic gates as well as switching application as well as the amplification purpose also, as well as in the communication related part also, they are going to use the MOSFETs itself. So once we understood about the small signal equivalent model, so we have started analyzing the high frequency model. So high frequency model, why? Because so when we are dealing with a MOSFET as an amplifier, so the amplifier performance will not be same over the wide range of frequency. So for an amplifier, so a very important parameter is it should have a higher gain. At the same time, the gain along with that bandwidth is also a very important parameter for any type of amplifier is concerned. So for that, so how much frequency or what will be the bandwidth? So higher the bandwidth, so all required that any amplifier should have higher gain. So that means larger gain is required. At the same time, the bandwidth should also be very high. So that means bandwidth should be very high means what? So it is nothing but so it must provide a constant gain over a band of frequencies. So that is called as a bandwidth. And in order to find out the bandwidth for any amplifier, we can see that what will be the bandwidth for a corresponding common source or any type of amplifier is concerned. So there are MOSFET amplifiers. We have seen in detail about the common source amplifier. So when we see that the amplifier performance was constant in the midband frequency, and over the lower frequency range as well as the higher frequency range, so we can see the gain falls off. So that gain falls off. What are the parameters? What are the effects which causes the gain to fall off at lower as well as higher frequency? We have seen. So low frequency response of common source amplifier as well as higher frequency response of common source amplifier also we have seen. At the same time, characteristics parameters for an amplifier we have seen for both the case, that is a common source amplifier along with the source followed. This is also called as a common drain configuration. So having understood the configuration as well as having understood about the frequency response, how it is going to vary with respect to the frequencies, we have developed a high frequency equivalent model, and for that it is also called a hybrid pi model also. So that is a high frequency model we have developed, and at the same time, so we have seen what are the causes for the high frequency model. Means we know that the internal MOSFET capacitance is going to cause the gain to get roll off. So when the gain getting roll off, so we have seen what are the important capacitance. There is internal MOSFET capacitance which is going to cause the gain roll off. So gate to source capacitance as well as the gate to drain capacitance. So both the capacitance, there is a gate to source as well as gate to drain, it is going to cause the gain to getting roll off in the amplifier section. And after finding all this, so we have started with the applications related to amplifier. So that is the oscillator circuit. So in the oscillator circuits, so for a given common source or common emitter amplifier, we have considered. So we have seen three basic categories. So one is RC phase shift oscillator, so which is having a main amplifier section as well as feedback phase made up of feedback network, which will be connected in parallel with respect to the amplifier. So the output of the part of the output will be given as the input to the feedback network, and output of the feedback network is again fed back to the input. So in those days, we can see that oscillators work with respect to positive feedback, and in that we can say that mm, the positive feedback of the amplifier will cause will cause the sustained oscillation. At the same time, so we have seen, so what are the conditions that is to be satisfied, and we have seen what is should be the loop gain for a given feedback. So we have seen. So about that parameters, we can see for the both RC phase shift oscillator and LC tank circuit also we have seen, and finally we have studied about the concept of crystal oscillator as well as the Pierce oscillator also we have seen. So among all the three, so crystal oscillator is having a very high Q factor, so parity selection factor parameter, as well as it is going to provide a stable oscillations even after variations of any temperature or environmental condition is considered, or if it is concerned with respect to for any case, that is if there is any changes in the fluctuation in the component values will not have any effect on this one. So because of that we are going for a crystal oscillator. So that crystal oscillator is going to provide sustained oscillation, and we have seen the electrical equivalent circuit of the crystal. So crystal and what are the various types of crystals that are commonly used in the practical purpose, that is Rochelli salt, tourmaline, and as well as quartz crystal we have seen. And among these, quartz is mainly used because of its low cost effective, as well as it is going to have a high piezoelectricity as well as a high mechanical deformation. So it occurs in between this Rochelli salt as well as tourmaline, and hence quartz will be the main thing that are going to be used in digital circuit as well. So digital circuits like smartphones, laptops, as well as personal computers, as well as all the signal processing, all the digital logic circuits. Digital circuits will be embedded with this crystal oscillator, because for all the crystal oscillators or for all the digital circuits, so main thing, all the functioning of all other circuits will take place with respect to the oscillation of the clock oscillation. So clock plays a major role. So clock circuitry will be designed based upon this oscillator. So oscillator is going to provide sustained oscillation, and it will be not providing any shift or fluctuation in the oscillation will not be there. Hence, oscillator will be the main part in any of the digital circuit. So, crystal oscillators, how it is going to vary with respect to its crystal reactance, because of it is going to have a two resonance frequency, because whenever we know that crystal is going to have a work with respect to piezoelectric effect. So piezoelectric effect we have seen, and based upon the external mechanical information, it is going to provide an alternating current, or providing an alternating sinusoidal variations, so oscillations across the output. So based upon that, the crystal is going to provide a sustained oscillation, and it works with respect to two frequencies. So one is series resonance frequency as well as a parallel resonance frequency, and series resonance frequency as well as a parallel resonance frequency. So series resonance frequency occurs across a lower frequency, at a lower frequency range itself. The series resonance will occur, and parallel resonance frequency will occur at a higher frequency, right? Between these series and the parallel resonance frequency parameters, so the reactance exhibited by the crystal will be inductive type, and apart from that, crystal reactance will be of a capacitor only. And based upon that, we have seen the alternative arrangement of the Colpit oscillator. So Colpit oscillator, another configuration. So one best example is the PS oscillator, in which the same type of Colpit oscillators. Colpit oscillator means two capacitors C1 and C2, along with crystal has been connected parallel to that of the CMOS inverter amplifier, and which is going to provide a sustained oscillation. So that is what it is going to provide an inverter. So since the output to input, it has been fed back with a feedback resistance, it is going to provide a continuous oscillation based upon the crystal oscillator, along with the Colpit configuration. So that is going to seen. So that is about the oscillator topic. So after that, we are now moving to the feedback amplifier. So in the previous oscillator circuit, we have just considered feedback element. So that feedback element we have just considered, and that feedback element, so that is also considered, that can also be considered as an amplifier, and because of which you are going to get gain. So that gain, loop gain, so in which we can say that the gain which is going to connect in parallel with respect to that main amplifier, so that is going to provide a loop gain, so which is nothing but a into beta. So whereas a corresponds to the open loop gain of an amplifier, that means whenever amplifier is not having any feedback, then the gain which you are going to get is nothing but an open loop amplifier. And the same time, if you are going to have a gain which is connected back to the input, so whenever the amplifier is connected back to the output, is connected back to the input, so it may occur in two types. One is the positive feedback as well as the negative feedback. So the way in which the feedback is given and mixed with the input signal, so that corresponds to the type of the feedback. So based upon these, so many applications we have seen. So many applications are there that we are going to see in the next two modules. So that is fourth and fifth modules, we are going to see completely with respect to negative feedback. And so this oscillators works with respect to the positive feedback. So positive feedback in the sense, so whatever the feedback is given, so it is going to add with the add whatever the feedback signal which you are going to give from the feedback element, it is going to add along with the input signal. So whenever the input is going to add with the feedback input, so obviously the output of the amplifier is going to that is going to increasing only. So there is no point in decreasing. So always the amplifier output will be getting, since the part of the output is being given as a feedback. So feedback, if it is going to add with along with the input signal, obviously the feedback signal is also going to increase. At the same time, the output is also going to continuously increase. So continuously, if it is increasing means, then there is no point in controlling the gain. So you will be not having any control over the gain, and it is going to continuously increasing means, so you can't able to control the gain. So that is why, so we can say that operation can be useful for oscillators and all. So in oscillators also you can see, so part of the output will be given as given to the input, will be added with the input signal, so that you will never find the gain getting roll off. That means the gain will not come down. That means output will not come down. Neither the output will not increase. So such a way that we are going to make the circuit elements such a way that, so it is going to how much the gain is going to, how much the amplifier is going to increase. That at the same time, feedback network is also going to reduce. So like that configuration we are going to keep in the oscillator. Because of that reason, so you're going to because of that reason you're going to get a sustained oscillation. So as long as the beta, as long as the amplifier gain is going to be increased by a factor that is going to be reduced by the feedback network, so that is a loop gain is maintained equal to 1, so you will be getting the sustained oscillation. That means so you will be not neither getting the too large nor too small. Because of that, so you can get a sustained oscillation. So this is just an example, typical example for the positive feedback is oscillator circuits. Okay, so for the coming to the inverting, so negative feedback. So this chapter will be working with respect to feedback only. So coming to the feedback, so all the existing systems, so whatever the important physical systems are there, so all these are working good to work with respect to feedback concept only. So feedback plays a major role in any type of amplifier is concerned, or in any type of application is concerned. So in order to maintain a suitable constant feedback is very important. So I'll just give an example. So in that only you can assume, so feedback can be easily assumed. So you are aware of that we are teaching in the class, and for that this is nothing but a amplifier. So amplifier, there is a feedback system. So I'm just giving a feedback system. So we are teaching the classes for all the subjects. We are teaching one faculty. We are teaching, and that for that we are going to have a input is the but your students, and these students will judge the basic will judge so how the subject is going on, and how the difficulty of the subject, how clearly the faculty is going to teach, and how clearly he is going to solve the all your doubts. All these things parameters will be given for you people, so that you are going to give the feedback about the class teacher, so feedback about the subject teacher. So based upon that we can able to correct ourselves. So if we are going to teaching too much time, so too much lengthy or too much less explanation if it is given for the student, then obviously so they will ask for more explanation, all these things. So that is nothing but the feedback. So how the faculty has been teaching, so for that you are giving externally, so that is nothing but the feedback. So it can be of two types, so that is a negative feedback is also there, as well as a positive feedback also it will be there. So just correlate with yourself, so that it will be a good example for you people. So negative feedback in the sense, so whatever the input is there, so that is going to be feedback signal is going to have a reduce, which is going to get subtract with the given signal. Feedback signal is going to subtract with the main input signal. The input signal will be the transmission source, that is nothing but the faculty who is teaching, and feedback is nothing but your audience. So this audience, if he is giving if he is going to find out all the negatives on the given faculty, then that is nothing but negative feedback. Okay, so that is feedback. So obviously the difference between the input signal and the feedback signal is obviously it is going to be get subtracted, means obviously it is going to be less. So that is why, so you're going to have the negative, that means it is also called as a degenerative. So it is going to reduce the amount of the input signal to be given to the amplifier. So amplifier again, so if it is xi minus xs, so I will just tell xi minus xf, if it is going to subtract means, so obviously so you are going to have a reduction in the input to the amplifier. So that is nothing but a negative feedback. And the positive feedback means obviously, so whatever the faculty is doing, so that for that even the audience also it is going to tell their opinion in the positive manner, means obviously for the amplifier input, so you're going to add up, so add up the signal. So because of the adding of the signal, the amplifier will still it is going to amplify the amplify to get the output to get increase always. So always it is going to increasing in manner such a way that you cannot have any control over the gain. So the gain is also going to increase because the output is going to increase. So output will be given to the feedback, and hence the feedback is again going to add with the input signal. So normally the output, previous output compared to the previous output, the next output will be still increasing only. So still increasing means obviously the output feedback is also going to increase at the same time. So it is going to add with this one, so that always it is going to continuously increase, and hence we cannot have any control or over the gain. So that is how the positive as well as the negative feedback it is going to work. So at the same time, the electronic components also. So among giving this among this the feedback system among those feedback amplifier. So soon after the invention of the feedback amplifier in the 1928, so the technique of this feedback is completely useful in all the electronic field industry. And since then, so many electronic circuits have been done without the feedback. So there is no any other systems is existing. So all these existing physical system is continuously depend upon either one or the other feedback system component. So that is about the feedback amplifier. So this feedback can be either negative or the positive feedback, as I told. So negative feedback will be called as a degenerative feedback, and positive feedback is also called as a regenerative feedback. So the word this degenerative has been used in the module 1, where we have used. So we have used in the common emitter with common emitter in the case of emitter resistance adding in series to the emitter terminal. At the same time, source resistance has been added with respect to source. So that in the bias networking problem, so we have seen that this resistance RS or resistance RE, it is going to act like a negative feedback, and it is going to be called as a degenerative resistance ಅಂತ ಹೇಳಿದೆ. So that is where we have used the word degenerative. So degenerative means you should understand that is a negative. So degenerative resistance means negative feedback resistance anta. So any increase or decrease in the voltage or the current is going to be used, and it is going to reduce by how much it has been increased. So that is the operation of the negative feedback resistance, or it is also called as a degenerative resistance. And the feedback can be of a positive type also. So positive we have seen. So we will also see an example in the operational amplifier, which will be done, which will be doing in the module 4 and module 5. So in which we are going to see the positive feedback. So schematic trigger, you might have observed the schematic trigger circuit, mono 555 timer circuits and all, which we will be conducting in lab as well. So in that it is going to provide a constant oscillation, and it is going to provide it is going to employ a positive feedback. So based upon this positive feedback, you are going to get it. So either the main bridge oscillator, massive phase shift oscillator, or any type of oscillator is concerned, so you are going to see that the feedback employed is nothing but a positive feedback. And in this chapter, we are going to study some what are the importance of negative feedback, because already we have seen so some example as well. So negative feedback, what is the effect of this negative effect, and what are the important properties of the negative feedback you are going to see. So in this feedback amplifier chapter, you are going to study in detail about the negative feedback. So negative feedback and what are the important properties that we are going to obtain. So that is what are the important properties of the negative feedback on the system, which you are going to see in detail, and we are going to verify the importance of these properties. So there are basically 5 important properties of the negative feedback. So because of which it has gained importance in the amplifier system. So in the amplifier, so negative feedback has caused a very important thing. So because of these important properties, it is going to have. Because of these important properties, so it has been accepted everywhere, and in any amplifier, so feedback plays a major role. So what are the important properties? So we are going to see. So first important property is the important desensitizing the gain. So desensitize the gain means what? So gain means nothing but an amplifier. So amplifier will be having certain gain. So for that gain, so we are making desensitized. That means the gain will not depend upon external things. That means so we are making the gain desensitivity. So gain desensitivity. So either you can call desensitize the gain or gain desensitivity. Desensitivity means what? Sensitivity means what? Sensitivity means for any change in the input or any small change in the input, so will cause change in the output by a larger amount. So that is nothing but the sensitivity. So smaller change in the external parameter or smaller change in any of the system will cause the gain to increase or decrease. So in order to avoid that, so if I make such a system, if I employ negative feedback, so your gain will become desensitized for any external changes. So that is nothing but gain desensitized. That is what he has explained over here. So that is desensitized the gain is nothing but so making the value of the gain. So making the value of the gain less sensitive to variation in the value of circuit components. So circuit components such as might be caused by changes in temperature, as I told. So if there is any changes in the external environment, or if there is any changes in the components value circuit, so this the gain should not depend upon the values of the external changes. So that is nothing but desensitivity of the gain, and that is very important thing, and we are going to see in detail what you mean by desensitivity and all. So, and the second thing is the reduction in non-linear distortion. So, non-linear reduction. So, reduction. So, reduce non-linear distortion. So, distortion means it is not acceptable in any type of amplifier is concerned. Non-linear means so for any given input, so the output should be linear with respect to input, right? So that is the limit of linearity. Whereas non-linear means so it is going to have a non-linear behavior. So since we are all having the electronic components associated with that, so all the electronic components since it is going to have so your transistor, diode, or any type of consider, so all will be having non-linear behavior will be there. So when you are going to have this in the amplifier circuit, you may exhibit so non-linear behavior or a non-linear distortion may take place. So by employing the negative feedback, it is going to reduce the non-linear distortion in the existing system. That is what, so that is making the output proportional to the input other than making the gain constant independent of signal level. So that is what it is a meaning that. So making the gain to be they're making the output proportional to the input such a way that you're going to make the gain constant. Gain will be constant. How we can make the gain constant? So other words, so making the gain constant is not suppose if you are having your non-linear behavior, so output if it is going to change for small change in input, if the output is going to change in the very last change means obviously it is going to have a non-linear behavior. So making the output to proportional to that of input is nothing but so for 20 amps for 10 amps of current, so 20 voltage, suppose we are going to have a 10 volts output you are going to get for a small 10 milliamps of current. Suppose if you are going to increase for a 20 milliamps of current, so the same way the output also it is to increase by the same amount rather than increasing it drastically. So 10 volt of increase for 10 milliamps means 20 milliamps if I am going to produce the current means 20 volts you should have. That means the gain should be constant. So that gain if it is being constant means that means you are reduce the non-linear distortion. That is nothing but making the output proportional to that of input. So 10 volts divided by 10 milliamps, so that is the resistance. So if you are going to keep the resistance constant, so that is the resistance must be kept constant such a way that so output is also proportional with respect to that of input. And the third important property of the negative feedback is reduce the effect of noise. So that means noise is a very important parameter in all the communication parameters or communication related equipment. So noise plays a major role. So that noise the noise across you will be knowing with the Gaussian noise, glitter noise, short noise. All these are nothing but a noise. So when you are studying in the communication related communication subject, so you will be going through this noise. So this noise is nothing but an unwanted signal. So unwanted signal. So that is going to corrupt the main input signal. So we need to reduce the noise in any type of electronic equipment. So any side of electronic equipment means so in if amplifier is considered. So at the input side, so whenever within the when you are going to connect to any one component to another component, so obviously there will be some electrical noise signal. So that is nothing but electrical glitch. So glitch can also be considered as a noise. Okay. So electrical glitch will be there. So that glitch and all. So it is going to consider it is going to be considered as a normal signal instead of that as a noise. So that is what it is going to predict. The glitch also will be considered as a noise signal. So we need to on employing the negative feedback, it is going to reduce the effect of noise signals that are going to be present in the inside the circuit. So that is what the importance of the third important property of the negative feedback. So it is going to reduce the effect of noise, that is minimize the contribution of output of the unwanted electrical signal generated either by the circuit components themselves or by external interference. Extraneous interference means when you are connecting one component with another component, so whenever component is connections are there, there will be you can exhibit them component glitches or something like that. So when you turn on the power, so you will be experiencing some electrical glitches. At the same time, even the components, circuit components are also going to perform. Either the components is also going to provide some noises, that is in the form of electrical noise it is going to provide. So when you employ negative feedback, it is going to be avoided and it is going to be reduced in the case by affecting them by reducing the effect of the noise. And it is going to control the input and output impedance. This is very important parameter. So for any amplifier, so you will be seeing that the operation amplifier, so the characteristics of the amplifier we will be seeing. So high input impedance will be there. So what are the important characteristics of operation amplifier means high input impedance, low output impedance, high gain, high bandwidth, slew rate should be less, slew rate should be more. So all these things we have seen. So what is the importance of higher input impedance and lower output impedance? So what is that required? Because why can't be higher output impedance? Why cannot be lower input impedance? So all those things you are going to see in detail. So it is going to on employing the negative feedback. So when you employ negative feedback, it is going to increase the input impedance. So open loop amplifier. So open loop amplifier relay, what will be the impedance? So you can say that suppose if you are considering the common source amplifier, so common source amplifier ಅಂತ consider ಮಾಡಿದ್ರೆ, so input impedance is going to have gate and source. So between the gate and source, input impedance will be that will be ideally it will be infinity because there will be no current flowing. So that means the input impedance will be higher. So that means it will be equal to infinity. So with this high input impedance, effectively all the input signal will be appearing across the all the input signal will be appearing across the input side of the amplifier without any loss. So that is what the important requirement of that higher input impedance. So if you employ negative feedback, still the input impedance is going to increase at the same time. So the output impedance is going to be reduced by a factor. So that is what the importance of the negative feedback. It is going to increase the input and output impedance. So it is going to control the input and output impedance. That is the limit. Controlling the input and output impedance is the limit. It is going to increase the input impedance and it is going to reduce the output impedance. That is raising or lower the input and output impedance by selection of appropriate feedback topology. That means appropriate feedback. So voltage, you'll be learning what are the different feedback topologies, voltage series, feedback. So voltage series, so there is shunt, uh, series, series. So four feedback topologies we are going to learn. So among these four feedback topologies, if you are going to employ anything, so you are going to obtain, you are going to increase the or reduce the input impedance or output impedance. So based upon the feedback topologies, it is considered and it is connected across the input side or output side. So if it is input side is connected in series fashion or parallel fashion, as output is considered with the series or parallel. So by the application of feedback network, it is going to control the input and output impedance and extend the bandwidth of the amplifier. So this is very important thing. So it is nothing but what? So extend the bandwidth of the amplifier indicates what? The bandwidth will be extended. For any amplifier is concerned, so bandwidth must be increased. So that means bandwidth must be high. So when compared to without feedback, so the bandwidth will be very less. On employing negative feedback, so bandwidth of the amplifier is going to increase. So all these five important points we have seen. These are all nothing but the advantages of them. There is the important properties of the negative feedback. Whenever you employ the negative feedback, so the gain will become desensitivity, and it reduces the nonlinear distortion in the output, and it is going to reduce the effect of the noise. So and it is going to control the input and output impedance at the same time. So it is going to extend the bandwidth of the amplifier. So these five important properties are there for the negative feedback. So not with respect to positive, it is negative feedback is going to have these five properties. So at the same time, it is also having one negative thing that is there in the negative feedback. That is, so all these important properties are there, but it is going to have the one drawback is all these important properties are going to be expense at the reduction of gain. That means, so in the negative feedback, you will be not having the larger gain when compared to that of open loop amplifier gain. So on the open loop amplifier in the gain, no? So that gain, if you consider, and the feedback amplifier gain, if you consider, the gain obtained from the feedback will be very less when compared to all these important properties. So these are all some of the important property, and the only drawback in the feedback amplifier is negative feedback amplifier is it is going to have a reduction in gain. Okay, so it is going to have a reduction in gain. So in short, the basic idea of negative feedback is to trade off the gain and the desirable properties. So gain, if it is not important parameter in your application, so when compared to these important properties means so you can go for the negative feedback. If gain is very important means you cannot go with the negative feedback system. So you can go for a positive feedback. So you're going to have only drawback in the negative feedback is the reduction of gain will be there at the expense of these important properties. Okay, so these are the five important properties of the negative feedback. So next we will come to the general feedback structure. So general feedback structure, how the feedback structure will be there. So here you can see this is the general feedback structure of the amplifier, general structure of the feedback amplifier. So this will be the source. Source is going to provide the signal transmission. So it is given as a source signal is represented as a XS. So XS corresponds to source signal, and this is the amplifier input. So if you are not having any feedback network or feedback amplifier is not there, then directly the source will be given to the input to the amplifier, and this amplifier is going to provide the output. So similarly you have seen in the common source amplifier or common gate amplifier or any common drain or common gate amplifier we have seen. So input signal source will be directly connected with the source resistance will be connected to the input side of the gate. So input side of the gate put together, at the output side of the amplifier, that is the output across the drain in the case of MOSFET, and in the case of BJT it is the name of the collector side in the. So we are going to provide an external load resistance RL will be there. So therefore that RL we are going to connect the output signal. So we have seen only these three important blocks, right? So this three blocks we have seen, so which is consisting of a source signal and amplifier as an transistor. So this source as a voltage or current can be acting as a source, and this amplifier will be considered as a BJT or an MOSFET, any three different configuration which can be common emitter, common base or common collector, or common source, common gate or common drain configuration that will be treated as an amplifier network. And across the load it will be considered as a load resistance RL. So wherein which you're going to get the output voltage or current to be developed across the load part. So for this amplifier, if I am going to employ a feedback network, so which is going to have a feedback gain, that is having the feedback amplifier is going to have a feedback gain as beta, and the main amplifier is going to have a amplifier gain as a. A is the gain of the amplifier, and beta is the feedback network, so gain, and part of the output. So output signal X naught is the output of the amplifier. So this output of the amplifier is given to the load as well as the given as input to the feedback network as well. So the output for this feedback network, so output of the amplifier X naught will be treated as the input signal. You can see the signal flow diagram of this amplifier. So output of the X naught will be treated as input to the feedback network input, and the output of the feedback network, which will be treated as the XF. XF corresponds to the feedback signal of the output of the feedback signal is denoted as XF, and this XF will be subtracted. So you can see this is nothing but a summer circuit. So wherein which it is going to subtract the input signal, source signal XS, and the feedback signal XF. So XS minus XF, so that is going to result into the input signal to the amplifier. So XI will be equal to XS minus XF. So that means source signal will get subtracted from the feedback signal. So since the feedback signal is going to have a subtraction, so it is going to getting subtract with the source signal. So obviously the input of the Xi, so input of the amplifier, that is Xi, is going to have a very small value. So this small value will get amplified across the output, and then it is going to provide the output amplified version of the output signal. It is nothing but the X naught. So this is how the general feedback structure of a feedback amplifier structure. Is it clear? So source block will be there, amplifier block will be there, load block will be there, and at the same time feedback block will be there. So in this the negative feedback, so you're going to subtract the input signal source from the feedback signal. So because of that you're going to have a negative sign. So because of this the feedback is subtracting with the source signal, it is called as a negative feedback. Suppose if it is a positive feedback, the same circuit general flow diagram would be there. So the same general feedback structure would be there. Only thing is that it was having a plus. So the input signal source will be added with the feedback signal. If it is going to add with the signal feedback signal, then obviously Xi will be increased, and this increase will have increase in amplitude, and hence the feedback structure would be resulting as the positive feedback. Whereas here the feedback is subtracting with respect to the signal source, hence it is called as a negative feedback. If the feedback signal is going to add with the source signal, then it is called as a positive feedback. So this summer, the circuit is going to subtract the signal source to the feedback signal, so resulting in the difference in the signal denoted as Xi. So Xi is nothing but Xs minus Xf. So that is nothing but Xi signal will get amplified. So this is the nothing but general feedback amplifier. So the same thing here is written. So basic structure of the feedback amplifier we have seen. So rather than showing, so whatever the input signal source can be of voltage or current, so we are going to generally we are going to show it as a signal source, and the signal flow diagram. So how the signal is going to flow across the that structure, that is nothing but a signal flow diagram. And we have seen we can represent either signal source can be of voltage or a current signal source. Okay, so quantity can be either a voltage quantity, voltage signal quantity, or it can be a current signal quantity. And then so we'll see. So open loop amplifier has a gain A. So we have seen the amplifier A will be having the open loop amplifier gain, and X naught is related to Xi. So X naught will be equal to what? So if I am not considering the feedback, so X naught will be equal to A times of Xi. So that is nothing but amplifier gain. So amplifier gain is given as what? So output is nothing but X naught. Input to the amplifier is Xi. So X naught will be equal to A times of Xi. So you can see the amplifier A. So output is nothing but X naught, and input is nothing but Xi. So the amplifier open loop gain is nothing but X naught divided by Xi. So that is X naught will be equal to A times of Xi. So output X naught is also fed to the load. So that is given to the load RL, the load block, as well as it has been given as input to the feedback network as well. So which produce the output, which produce a sample of the output voltage that is going to be provided, and XF is the limit output of the feedback signal. So and X naught will be acting as an input to the feedback network. So you can see this is a feedback network, feedback amplifier, for which the output of the amplifier is fed back to the load, as well as it has been given as input to the feedback network. So upon giving the feedback X naught input to the feedback network, so XF is the output provided by the feedback signal. So for this feedback gain is given by what? XF will be equal to beta times of x naught. So that is nothing but you are going to get. So xf will be equal to beta times of x naught. So that is what you are going to get, and you can also see that xi will be equal to, that is the input signal to the amplifier, xi will be equal to xs minus of xf, xs minus of xf. So that is the difference in this signal source with the feedback signal. So the feedback signal xf gets subtracted from the signal source xs, so which will be given as an input to the complete feedback amplifier. So this is nothing but input signal to this one. And then so the source, so we can, so now we can able to find out what is the feedback upon employing the feedback network. So what will be the gain associated with the structure? So what will be the gain associated with the structure? So the gain associated with the feedback amplifier is nothing but x naught divided by xs, right? So that is nothing but feedback. So upon giving the feedback voltage, so from the output voltage to the from the output signal signal to the input signal. So if I'm going to find, so x naught divided by xs, that gives them overall gain associated with the feedback. So that is nothing but feedback gain. So AF, so I'm going to represent A as a amplifier gain with feedback. F corresponds to feedback. So if I'm going to have only A, that is nothing but amplifier open loop amplifier gain. If I'm going to specify F along with the suffix as F along with the A, so that is nothing but feedback gain. So that feedback is what? So this is a negative feedback. So the feedback of the amplifier is going to have x naught divided by xs. So x naught is what? So you can substitute x naught is equal to what? So a times of xi, and xs is equal to what? So I'm going to substitute xs is equal to what? Xs is equal to, so I can write, so xs is equal to what? Xi plus xf. So I can write from this expression 5.3, xs signal source xs can be equal to input signal to the amplifier xi plus xf. So the same thing I have just written over here to find out them again. So x naught is given by a times of xi. Xf is the limit of feedback output, so that is the output of the feedback network. It is given by beta times of x naught. Xi will be equal to some difference of the xs minus xf. And now if I want to find out the gain, feedback gain AF will be given as what? X naught divided by xs. So x naught is equal to what? So from this expression I can write x naught is given as what? A times of xi. So I can write as it is, whereas xs is equal to what? So xs I can write from this one, xs will be equal to xi plus taking it to the left hand side, so xi plus xf. So xi plus xf, so xf is equal to what? So xf is equal to beta times of x naught. So I can substitute xf is equal to beta times of x naught. So again x naught can be written as what? So x naught can be written as a times of xi. So x naught can be written as a times of xi. So totally you will be having xi over here as a common, which will be equal to 1 plus a into beta. So I can substitute xs is equal to what? Xi into 1 plus a beta. So I will be substituting the same thing. Xs can be written as xi into 1 plus a beta. So this is the feedback gain. AF is given by x naught divided by xs. X naught is nothing but a times of xi. Xs is given as xi into 1 plus a beta. So xi will get cancelled, and you will be getting the feedback gain AF for the negative feedback is given as a divided by 1 plus a into beta. Okay, so this is the feedback gain, and this thing you should remember throughout this chapter. So it is very important. So again, in so many expressions and all it will come. So feedback gain means you should remember a divided by 1 plus a into beta. Okay, so with this topic, I'll just conclude today's class. So this is the today's chapter. We have studied the general feedback structure, and we have obtained the gain expression for the negative feedback. So negative feedback in the gain expression is given as what? X naught by xs, which will be equal to a divided by 1 plus a beta. So this is nothing but feedback, and the concept a into beta, which we have already studied. So a into beta corresponds to the loop gain. So okay, loop gain, it is denoted as a into beta. So with this I'll just wind up today's class. So we'll meet you tomorrow. Okay, thank you. Whether people are understanding or what?